Ladies and gentlemen, boys and girls, another time we meet to talk about a concept that we apply in our daily lives, specifically photoelectric effect. What is photoelectric effect? Let's look at some of the gadgets in our real life that we apply this concept. The photons hit the camera sensors, the light sensors, to be able to turn electrical signals into image. So that is how our digital cameras work in our smartphones. In the solar panels that we have and as an alternative to energy that we have, the solars also use the same concept. Light eject electrons from the metallic surface to generate electricity. The automatic doors will step ahead to find a simulation that can help us understand the photoelectric effect. Remember, this is simply a phenomenon whereby an instant radiation that has a sufficient frequency is able to eject electrons from a metallic surface. At that level, it means the radiation doesn't have sufficient frequency to be able to eject electrons from that surface. I want us to use the UV. I want us to use the ultraviolet radiation. And then we increase intensity to 20%. Now that shows the incident radiation, the photons. Photons are simply the energy packets that are contained in light. Now, as we can see, as they bombard that metal surface, they are able to eject. Initially, it was not able. But since we're using the UV, it means it has sufficient frequency or the energy to eject electrons from that surface. Now, let's see what happens when we increase the intensity of the incident radiation. What happens when we increase the intensity of the incident radiation to around 83%? You discover that more electrons are ejected. In other words, that also affects photoelectric effect. When we reduce the wavelength of the radiation, in other words, increase the energy, we can see that also the amount of ejected electrons, we talk of the photoelectrons, increases in number. That energy of the photon is the same as the energy required to make it be in motion. In other words, to possess kinetic energy, and also it should be able to overcome the work function of the metal. Work function is that minimum energy required to eject an electron from the metallic surface. Now, with all this concept, I want us to look for a typical question to help you understand or apply what we have been demonstrating. Let's move to the question and see. Let us read the question. A metal surface has a work function of 2.3 times 10 power negative 19 joules. Light of frequency 8 times 10 power 14 hertz is incident on the surface. Take Planck's constant, H is equal to 6.63 times 10 negative 4 joule seconds. From the Einstein's equation, the photon energy is equal to the work function of the metal plus the maximum kinetic energy of the photoelectrons. We can replace this by using HF, in which H is the Planck's constant, F is the frequency of the incident radiation, work function, like that. Then we have the kinetic energy. Now, the question asks us, calculate the energy of one incident photon. Energy of a photon from Einstein, we talk of HF. H is the Planck's constant, 6.63 times 10 power negative 34. The frequency is 8 times 10 power 14 hertz. 5.3 times 10 power negative 10 joules. This is energy. Question 2. The kinetic energy, the subject of the formula, which I have HF minus work function. HF is the energy of the incident radiation. We have found above it is 5.3 times 10 negative 19 minus the work function. We have been given work function 2.3 times 10 power negative 19 If you do this one, you will get 3 times 10 power 19 joules. Explain why electrons are emitted immediately when light falls on the metal. We simply say that the incident radiation have sufficiently higher frequency, therefore it has higher energy than that of the metal's work function. That's why it is able to eject electrons immediately. Remember, we always say that the incident energy must be more than the work function of the metal for photoelectric effect to take place. Let's go to part D. State and explain the effect of increasing the intensity of the incident light while keeping the frequency constant. The energy of the incident photons is given by Hf. H is a constant, meaning we only vary F. So if F is constant, it means E will also be constant. Therefore, there will be no change. For this and more, do not hesitate to contact STEM Hub International. We are always there at your service. Always enjoy.